Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of what to look for in the night sky. We're talking about the week of July 21st. This time around, a good moon week. Easy to see a lot of stuff. We're going to explore some objects over here that are fun in the summer sky. The moon. Your best chance to see the moon is at the very end of the week on the evening of the 27th. It'll be about 10% full. So it'll be a beautiful crescent in the glow of sunset on that evening of the 27th. That's something to look for. We've been watching Saturn and Neptune. These two planets both move against the background stars, but they move very slowly, and they move in the same direction, and so they don't separate very much. So that's been a pair that's been sitting below the Great Square of Pegasus and the Circlet of Pisces, the sort of Pisces area, for quite a while now that we've been looking at each week. Still there, rising about 11 to 11:30, closer to 11:30 p.m., early in the week and 11 p.m. late in the week. Remember, the stars rise 4 minutes earlier every day, every night. As we orbit the sun, we have to over-rotate just a little bit to get the sun back overhead, and that's our 24-hour clock. Our rotational period is 23 hours and 56 minutes. Stars are so far away, they don't know that we've moved in our orbit, and so they rise 4 minutes earlier every night. And that's why by the end of the week it's closer to 11 if it's 11:30 at the beginning of the week. Venus is still bright in the morning sky. Jupiter is trying to rise into the morning sky. So keep an eye out for Jupiter. It rises about 4 to 4:30 by the end of the week. If you have a really good eastern horizon and you go out and you work at it, you probably have a chance to see Jupiter by end of the week as a bright dot just appearing over the horizon. I don't have that good of eastern horizon. I'm not going to be able to see it for another week or two, I don't think. But we're headed into Jupiter as an object in the morning sky as we move from midsummer to late summer and into fall. Okay, every week we've been drawing Aquila on the sky with bright Altair, one of our summer triangle stars. I think maybe this is the last one, and then we'll move on to something else next week. What we did last week is we dropped down to the tail. We think of this as a kite, and we dropped down to the tail of the kite, Lambda Aquila, is this bright star that's down here at the tip. And then we moved over 4 degrees to the beautiful open star cluster M11. And then we dropped down to another nice open star cluster M26, another 3.5 degrees down that direction. We failed to point out last week as we did this. Go ahead and observe those again this week. You have to refrain from observing them because they were last week's items. Remember, M11 is the most beautiful open star cluster we've got out there, in my opinion. We failed to mention that we were across the border from Aquila into Scutum. It is the constellation for both of these objects. And we think of that now because right next, less than a degree from M26 to the north and west, is the 4.7 magnitude variable star Delta Scuti. And Delta Scuti is a class of variable stars. So we have a prototype star. This is, here's a star we tried to figure out for a long time what the heck was going on. And then we see that there are other stars that look like that star. So this is usually the first of the stars that was discovered to have this type of variability. And then all the other stars are called, well, Delta Scuti type stars. And so that's a class of variable star that we work with, the Delta Scuti stars. And it's an interesting class because the variation is typically very rapid, and it's also very small in amplitude, and it has periodicity. And so that means it has one oscillation up and down, but there are other oscillating periods in there with smaller amplitudes. Some of these have been known to have a dozen different oscillations going on at one time. So these are very complex oscillating systems. Delta Scuti itself varies from about 4.6 to 4.8 magnitude, about 20%. If you're really careful in your observing, you might be able to see that. And again, I might suggest you take a picture. Use your phone or your smart telescope or whatever you've got and take a picture of M26 over the course of the night. Just take a picture every 10 minutes of M26. Bam, 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 bam. Why not? You get a bunch of beautiful pictures of M26, and then look for Delta Scuti up there next to it and see if you can see that it's getting brighter and dimmer. It varies from about 4.6 to 4.8 magnitude. Again, about 20% change in brightness. And the period to go from brightest to dimmest back to brightest is about 4 hours and 40 minutes. And so over the course of the night, you should be able to see it go from wherever it is to its dimmest point, to its highest point, and then back to wherever it started, and then maybe start through the cycle again. So that's a fun project to try. If you want to do something that's interesting and fun, see if you can measure the variability of Delta Scuti there. So let's drop down now. So we go about 10¼ degrees, almost straight south from M26. That's a fist width. And now we're in Sagittarius. And Sagittarius is the direction of the center of the galaxy. We're looking right down the heart of the disk of the Milky Way galaxy into the center of the galaxy. Star clouds, stars, clusters, nebulae, star everything all over the place. This is a rich region for exploration. M26 is a bright, somewhat sparse cluster compared to these others that we're looking at. It's not that sparse. Again, if you take a picture of it with your phone, or take a picture of it with your smart telescope or whatever you've got, it's going to be a great object. You'll see it in binoculars, but as you scan this whole region in binoculars, there's all kinds of fuzzy patches and clouds of stuff, and it gets very confusing because it's such a rich region of the sky. Again, as we look right down the heart of the disk of the Milky Way toward the center, it's such a rich region. But see if you can find M25 by dropping straight south about 1 fist width at arm's length of M26. Then you move over 3¼ degrees, a third of a fist width, at arm's length to M24. And M24 is really hard to figure out sometimes. It is basically what we call a star cloud. So we have these star clouds in the region of Sagittarius, which are just big, often undifferentiated. You don't see the individual stars. You just see these big glowing clouds. But there are individual bright stars in there. So it's a star cluster, a cloud. And then you move a 1⅓ degree, a little over a finger width at arm's length, straight north back up to M18. So we drop down, we drop over, and then we move straight back up. M18 is another scattering, another sort of sparse cluster in a star-rich region. So see if you can identify where M18 is as a condensation of stars amidst all of these stars that are out there. You know, Milky Way has 200 billion stars in it, and you see a lot of them. Look in this direction. And then you move up another degree or so from there, and you come to M17. I grew up thinking of M17 as the Swan Nebula. I think you see it as the Omega Nebula a little bit more now, but you'll see both names associated with this. This is a nice bright knot of gas. Should be able to see all of these in binoculars or the smallest of telescopes. Should be able to pull these things out. This is a bright knot of gas that is a star birth region. That you have spiral galaxies like the Milky Way. The disks of spiral galaxies are star-forming regions, rich in star-forming regions, lots of gas-making stars, and this is a great example of one of these. This is a large area. It doesn't look that large to your eye, but this is a big, vast star birth region in the Milky Way, one of the larger ones around. And then if you keep moving back up another 2½ degrees, again, sort of a quarter of a fist at arm's length, you just keep stepping straight back up to the north, you come to M16. M16 is one of the most famous star birth regions in the Milky Way, in the summer Milky Way. It's probably the most famous star birth region in the summer Milky Way. The Orion Nebula is probably more famous in the winter sky. But for the summer Milky Way, as we look towards Sagittarius, M16 is called the Eagle Nebula. We've crossed over the border into the constellation of Serpens. Remember, Ophiuchus is the big sprawling constellation that sits north of this region, and Ophiuchus is a snake handler. So you have the snake. You have the head of the snake on one side and the tail of the snake on the other side. And we've moved over into Serpens for the Eagle Nebula. And sometimes you might have seen these pictures out there of something called the Pillars of Creation. And you might have seen pictures of the Eagle Nebula where it looks like there's a landing eagle coming in. And then you see the close-up of these Pillars of Creation. That's this region. That's this nebula, M16. So M16 is another bright knot of gas. Wonderful rich. There's more stuff in the area, but this is a wonderful, rich region to explore. M26 to M25 to M24, M18, M17, M16. Drop down south, over to the west, and back up to the north, and see if you can find those objects. All beautiful in binoculars, all beautiful in even the smallest of telescopes. You have a larger telescope, it's going to be brighter, and you're going to see more. You have the ability to take photographs with your telescope, and you're going to see wonderful stuff in all this. One object, you got your telescope out there, and you want to try to take a picture with your smart scope. One of the objects, I would recommend the Swan Nebula or the Eagle Nebula. Let's do the Swan Nebula. You see pictures of the Eagle Nebula out there all the time. You can try to reproduce those. That'd be great fun. But I also would recommend, for something that's attractive and interesting and new, I try M17, the Swan Nebula, this week. But don't forget to see if you can track the brightness changes of Delta Scuti as you do this. That's it. That's what we got for you. A wonderful week. Not much moon. Go out and explore more stuff. Hopefully you have clear skies and you have a great week ahead. And as always, thanks for watching, everybody.